So, well, we are back on this art program. So, last class we discussed the differentiation of implicit function. Just I recall how to differentiate the implicit function and what is the implicit function. As we know that suppose the y is equal to f of x is given, it is said to be explicit function. It is explicit function because y is given in x. In place of this, suppose if we have f of x comma y is equal to 0, it means both x terms and y terms are included in the given equation. So, such functions are said to be called implicit function. Implicit function. You take the example y square plus x square is equal to a square. See, x term is there, y term is also there. Both x and y is expressed in the f of x comma y is equal to 0 form. X plus y is equal to sine of x plus y e power x y is equal to x square minus y square. Sine inverse of x plus sine inverse of y is equal to a. So, they are all example for implicit functions, right. How to get the derivative of implicit function, that is important here. You take any implicit function, it includes both x term as well as y term. Here we have to differentiate both x term and y term. How to differentiate y term? So, if it is y, we will write it dy by dx, correct. Suppose if it is root y, if it is y square, if it is sin y, if it is e to the power of y, then how to write or how to get the derivative of such functions or such terms which are in y. All y terms are differentiated similar to x term only, but at the end we will write dy by dx. You see, suppose if there is x square whose derivative is 2x. Suppose we have y square, how we have differentiated x square? We have put it 2x. Same type for y square also we have to write 2y, but at the end we have to write dy by dx because it is y term, y will be expressed in terms of x. Suppose if we have e power x, its derivative is what? E power x only. At the same time for e power y, we have to take e power y into dy by dx. Log x, differentiation of log x is what? 1 by x. Similarly, differentiation of log y can be taken as 1 by y into dy by dx. Suppose we have x into sin x, we will be differentiated using product rule, right. Suppose if we have x and y term, if they are in product or they are in quotient, there also we have to use product rule and quotient rule. Finally, whenever we come across y term, there we have to differentiate similar to x term. Finally, we have to write dy by dx. You see the given examples. Suppose if I take y square plus x square is equal to a square, here differentiation takes place on both side, y square and x square. How to differentiate y square? We have to put 2y into dy by dx. How to differentiate x square? It is already known, it is 2x. Differentiation of constant is 0. The dy by dx comes in the middle of the equation or at the beginning. Finally, we have to take dy by dx, all dy by dx term to one side, the other term to other side. Finally, we have to take dy by dx common, and the term along with the dy by dx, that is to be sent towards the denominator of the right side. I will show few examples here. If x cube plus y cube is equal to a cube, I am taking very simple example. X cube plus y cube is equal to a cube. Find dy by dx. The problem may be of this type. So, what is given? Given function is x cube plus y cube is equal to a cube. Differentiate x cube, that is 3x square. Differentiate y cube, it is similar to x cube. So, we have to write 3 into y square into dy divided by dx is equal to a cube is what? Constant, whose derivative is 0. Then you take the term which do not have dy by dx, that is to the right side. You transfer this 3x square, it will become minus 3x square, or we can reduce it to dy by dx. Dy by dx is minus 3x square all divided by the producted term for dy by dx is what? 3y square, that is goes to denominator of other side. 3 get cancelled. Finally, the answer is minus x square divided by y square. This is one example. You take another simple example, e power x plus e power y is equal to 4. Differentiation of e power x is e power x. Differentiation of e power y is what? E power y into dy by dx is equal to what? Differentiation of any constant is 0. You remain have the dy by dx at left side, and other term which do not have dy by dx, that is to be taken to right side. It will become what? Minus e power x. Finally, dy by dx is equal to minus e power x whole divided by e power y. This is answer. So, such problems we have to work out in more numbers to become masterized in differentiation of implicit function. I will show other examples. You take if e to the power of x plus y is equal to, or you can take plus sine of x plus y is equal to k. The given function is what? E power x plus y plus sine of x plus y is equal to k. We have to differentiate the given function with respect to x on both sides, because it is of equation form. It is what? E to the power of function. So, function is x plus y. If you differentiate e to the power of function, we get e to the power of x plus y into d by dx of x plus y, because it is a chain rule. E to the power of function derivative is what? E to the power of function into differentiation of function plus differentiation of sine of function. Here function is again x plus y. Differentiation of sine of function is what? Differentiation of sine cos of function into d by dx of function. What is function? X plus y is equal to differentiation of constant is 0, right? Then keep e power x plus y as it is, differentiate x plus y. What is differentiation of x? It is 1, plus what is differentiation of y? It is 1 into dy by dx, because it is y term. So, I will write only dy by dx plus cos of x plus y. Again differentiation of x plus y. What is differentiation of x? 1 plus differentiation of y is what? Dy divided by dx is equal to 0. Now, we have differentiated the whole terms. Now, what is our next job? We have to simplify for dy by dx. Hence, we have to remove all the brackets. 1 into e to the power of x plus y, e to the power of x plus y, plus dy by dx into e to the power of x plus y, that is e to the power of x plus y into dy by dx, plus again here also we have to remove the bracket. 1 is multiplied with cos of x plus y. This is whole single term. Cos of x plus y is only one term. So, this is multiplied with 1, you will get cos of x plus y, plus into plus cos of x plus y, cos of x plus y into dy by dx is equal to 0. So, we have removed all the brackets, then we have to collect all dy by dx terms together and others to other side. So, e to the power of x plus y into dy by dx, then plus cos of x plus y into dy by dx is equal to the term which do not have dy by dx. This is first term, this is the second term. Both should be transferred to the right side. So, it will become what? Minus e to the power of x plus y. This cos positive, when it is transferred to other side, it will become minus cos of x plus y. You take dy by dx common, you take dy by dx common, dy by dx is taken common. What we remains? E to the power of x plus y plus cos of x plus y is equal to minus, you take minus common, e to the power of x plus y plus cos of x plus y. Finally, you write it for dy by dx. Dy by dx is equal to what? This whole part will goes to denominator of the right side. So, they can cancel, correct? This and this, they are common, they get cancelled. Therefore, finally, you can write dy by dx is always equal to minus 1 here. This is one such example, right? We can go for another example. You take the function as sin x plus sin y is equal to k. Find dy by dx at x is equal to pi by 2 or pi by 3, any particular value you can take, right. You take differentiation of this sin. Differentiation of sin x is what? Cos x, plus differentiation of sin y, it is what? Minus sin y. It is y term, therefore, we have to write dy by dx is equal to differentiation of any constant is 0, right. Minus sin y into dy by dx is retained in the same side. The cos x which do not have dy by dx, that is to be transferred on other side, that will become what? Minus cos x. Then dy by dx is equal to minus cos x whole divided by minus sin y. So, minus minus cancel, it is what? Cos x divided by sin y. So, I have taken only x value, x is equal to what? Pi by 3. Suppose if y should also be given, y is equal to pi divided by 4. Y and x are given. Finally, you substitute at x is equal to pi by 3, y is equal to pi by 4. Therefore, dy by dx become cos of what is x? X is equal to pi by 3 divided by sin of pi by 4. As we know that cos pi by 3 is cos 60 degree, cos 60 pi by 3 is equal to cos 60, cos 60 is equal to root 3 cos 60 is equal to 1 by 2. Similarly, sin 45, sin pi by 4 is what? Sin 45, sin 45 degree is equal to 1 by root 2. If you substitute here, you will get cos 60 is 1 by 2 divided by sin 45, it is 1 by root 2, or it will become 1 by 2 into root 2 divided by 1, or it will become root 2 divided by 2. In other words, you can have 2 as root 2 square, because root 2 square is also 2, 2 square root cancel. Finally, the answer may be 1 divided by root 2. Finally, the answer may be 1 divided by root 2. Sometime after finding dy by dx, we have to put the given values of x and y to get the derivative of that function. Next, let us discuss the logarithmic functions. Logarithmic differentiation, it means we to find the derivative of some functions. Logarithmic differentiation. So, logarithmic differentiation is nothing but for some given function we cannot differentiate directly. So, let us take y is equal to sin x to the power of tan x. When we have function to the power of n, then we can use the chain rule to get the derivative of such function, right. Here what we have? We have function to the power of function. Y is what? It is function to the power of function. This cannot be differentiated directly. So, hence we have to reduce this given function into differentiable form. To get the differentiable form, we have to use the laws of logarithm. Using laws of logarithm, we have to reduce the given function into differentiable form, then we have to find the dy by dx. That is the differentiation of logarithmic functions, or we can say logarithmic differentiation. Is it clear? So, when the function to the power of function is given, we have to use laws of logarithm to make that function into differentiable. Then it is to be differentiated with respect to x, and finally, we have to find out dy by dx. That is the procedure to get logarithmic differentiation. You take y is equal to what? Y is equal to sin x to the power of tan x. Function to the power of function is given. What we have to do? We have to take log on both sides. Log on both sides. It will become what? Log y is equal to log of sin x to the power of tan x. as we know that log m power n is equal to n into log m, is it right? According to laws of logarithms, log of m power n is always equal to n into log m. According to that, it will become log y is equal to the power become index tan x into log of sin x, log of sin x. See, this is differentiable, this is differentiable. It is of what function? It is of implicit function. Log y is equal to tan x into log of sin x. Therefore, differentiate with respect to x on both side, Differentiation of log y is what? It is 1 by y into dy by dx is equal to differentiation of tan x into log of sin x. Differentiation of tan x into log of sin x, it is of product of two terms, they are to be considered as u into v. Therefore, we have to use product rule. Differentiation of uv is what? U into v dash plus v into u dash. V dash is d by dx of v, u dash is d by dx of u. According to that, you keep tan x as it is into differentiation of log of sin x plus log of sin x is to be kept as it is, v is kept as it is, differentiation of u. What is u? U is tan x. Then wherever we have d by dx, that is to be differentiated, other term are kept as it is, hence tan x remains same. Differentiation of log of sin x, it is log of function, is it right? How to find differentiation of log of function? It is similar to log x. Differentiation of log x is 1 by x, correct? So, according to that, log of sin x differentiation is 1 divided by sin x into d by dx of sin x plus keep log of sin x as it is, differentiate tan x. Differentiation of tan x is secant square x, right. Then if you take dy by dx is equal to the y goes to numerator of other side y into we have tan x into we have 1 by sin x into differentiation of sin x. Differentiation of sin x is what? Cos x plus here all the terms are differentiated, then we have to take only the remaining term, that is log sin x into secant square x. What is cos x by sin x? Cos x by sin x can be taken as cot x, it is nothing but what? Cot x. Cot into tan is what? Tan into cot is 1. Therefore, it can be taken as y is equal to tan x into cos x divided by sin x is cot x plus log of sin x into secant square x. Their product is what? Tan into cot is equal to 1, hence dy by dx reduces to what is y? Y can be replaced as sin x to the power of tan x, correct, it is given into tan into cot is 1 plus log of sin x into secant square x. This is answer for the question. Like that, you can take any term, it is of function to the power of function, then we have to go for logarithmic differentiation. Is it clear? What the procedure we have to follow to get the derivative of logarithmic function differentiation? The y function to the power of function is given. Suppose if the function to the power of function is given, then it cannot be differentiated directly. So, what we have to do? We have to take log on both sides like this. So, after taking log on both sides, it is taken according to law of logarithm. It is always comes, that is log m to the power of n is equal to log m. So, according to that we can take log y is equal to this power will become index tan x into log of secant x. Now, we have to differentiate on both sides. The right side is in the product of two functions form, there we have to use product rule. Is it clear? Finally, we need to get the dy by dx. I will take another example. Let us take y is equal to x to the power of cos x. Y is equal to x to the power of cos x. It is again x is function, cos x is another function, they are in the form of function to the power of function. What step we have to follow? We have to take log on both sides. When we take log on both sides, it will become log y is equal to log of x to the power of sin x. According to law of logarithm, log m power n is equal to n into log m, right. So, based on this rule, this reduces to log y is equal to sin x into power become index into log x. Now, it is differentiable form. How to get its derivative? You differentiate on both sides with respect to x. The right hand side is of the form u into v, product rule. Therefore, 1 by y into log y, it is implicit function. Product rule says that keep first function as it is, differentiate second function, plus keep second function as it is and differentiate the first function sin x. It is equal to sin x into differentiation of log x is what? 1 by x, plus keep log x as it is, differentiate the sin x. Differentiation of sin x is what? It is cos x. So, finally, you can write, it is not log y, derivative of log function is 1 by function into dy by dx of function, it is a y term, therefore, we have to put dy by dx. Then dy by dx is equal to y into sin x by x, correct. Sin x into 1 by x, 1 into sin x is sin divided by x, plus log x into cos x, that is equal to, you can replace y, otherwise you can write it in terms of y only, no problem. So, if you want to write in place of y, what is y? Y is equal to x to the power of cos x into the bracket sin x divided by x plus log x into cos x. Is it clear? You see the examples, other examples, use the slide. Y is equal to a to the power of x. So, a to the power of x is differentiated using logarithmic differentiation. First step, we have to take log on both sides, is it right? We have taken log on both sides, it will become what? Log y is equal to log of a to the power of x. Then it will become log y is equal to x log a log, then it is differentiated. So, when we differentiate log y, we will be having 1 by y into dy by dx, correct. Then log a is constant, we have to take log a as it is, differentiate x, differentiation of x is what? Dx by dx. So, dx by dx is 1, therefore, finally, it is dy by dx is equal to y into log a. So, in place of y you can write a power x into log a. So, that is why I have given this in standard form itself, a to the power of x is equal to a to the power of x into log a. You go through the second example in the slide, you take y is equal to a to the power of bx plus c. So, function is what? Function is y is equal to a to the power of bx plus c. Y is equal to a to the power of bx plus c. It is constant to the power of function. There also we cannot differentiate this power directly. There take log on both sides, it will become log y is equal to log of a to the power of bx plus c. So, this power become what? Index, hence log y is equal to bx plus c into log a, right, log a. Differentiate on both sides. So, differentiation of log y is what? 1 by y into dy by dx, that is equal to differentiate on right side. What is right side? bx plus c into log a. Log a is a constant. We cannot use product rule here because it is constant into function. Therefore, keep constant as it is, differentiate bx plus c. Bx, b into 1 plus c is 0. Hence, dy divided by dx is equal to y into log a into b. This b cannot be multiplied to this a, it is always taken to the right side, sorry, it is taken as index. Therefore, what is y? Y can be replaced as a to the power of bx plus c, hence b into a to the power of bx plus c into log a. Otherwise, you can write b into log a into a to the power of bx plus c, right. This is the another example. You go through few examples, x to the power of sin x, it is already discussed, x to the power of cos x. You take the given problem, x to the power of x plus sin x to the power sin x to the power of x with respect to x. It is sum of function to the power of function. It is sum of function to the power of function. Both are having function to the power of function. So, it will be little lengthy. So, I cannot work it on board. You just see the slide. I will explain there itself. So, y is equal to x to the power of x plus sin x to the power of x. Is it right? Here we have to take both separately, u plus v, u plus v. So, what is u? I will take u is equal to x to the power of x, right. You take u is equal to x to the power of x, then another function v is equal to sin x to the power of x. Then what is u differentiation? Again we have to take y as u plus v. Finally, we will arrive dy by dx by using du by dx plus dv divided by dx. So, there you differentiate u and v separately by using logarithmic differentiation by taking log on both sides. You take u, what is u? X to the power of x. Here we have to take log on both sides, then it will become what? Log u into log x to the power of x. Then x to the power of x, it will become what? It will be the log of function x to the power of x will become x into log x. Then you differentiate this. So, differentiation of this is what? Differentiation of log u, it is 1 by u into d by dx of u. So, how to differentiate this? That is 1 by u into du by dx, is equal to you take this differentiation of log u is equal to x into log x. If you differentiate this log u, it is function of x, therefore, I have to take 1 by u into log u, that is du by dx. It is differentiated using product rule u into v. So, x into differentiation of log x, that is 1 by x, plus keep log x as it is, differentiation of x is equal to 1. Then it will become u into 1 plus log x. From here x get cancel, x get cancel, u will go to the other side, this is u into 1 plus log x. You can check it in the next slide. See, u into this, what is u? If you want, you can substitute x to the power of x. At the same time, v is to be differentiated with respect to x. What is v? V is equal to sin x all to the power of x. Again, we have to take log on both side. Taking log on both side, it will become what? Log v is equal to log of sin x to the power of x. According to laws of logarithm, the power become what? Index, right? It will become index. So, log v is equal to x into log of sin x. You differentiate it, you differentiate this with respect to x, then log v, it is 1 by v into dv by dx is equal to, again we have to use product rule, x is u and this is v, log of sin x is taken as v. Hence, 1 by x into differentiation of this is what? 1 by sin x into differentiation of sin x plus log of sin x into differentiation of x. Finally, x into 1 by sin x into differentiation of sin x is cos x. So, differentiation of sin x is cos x by sin x will become cot x. So, that I have taken here. See, x into sin x into cos x plus log of sin x. So, cos into sin, it is taken as a cot, that can be taken, or otherwise you can keep it as it is. So, this x by sin x into cos x plus log of sin x. So, finally, we have to find dy by dx. So, we have taken dy by dx is equal to what? Du by dx plus dv by dx. You substitute du by dx value and dv by dx value, that will be the differentiation of function to the power of function plus or minus differentiation of function to the power of function. Next, this is an important problem. You take y is equal to root of sin x plus root of sin x plus root of sin x plus root of sin x. We have to show that dy by dx is equal to cos x divided by 2y minus 1. So, the given equation is taken as what? Y is equal to root of sin x plus y. How it will become plus y? Suppose you just leave this, you consider only this much, it is what? Root of sin x into root of sin x into root of sin x, correct? Root of sin x plus root of sin x plus root of sin x, it is equal to what? It is y, no. That is why by leaving first term, the remaining terms are again taken as what? Y. Hence, what is y? Y is root of sin x plus root of sin x plus root of sin x. Otherwise, you can take square on both side. You can take square on both side. The first square get cancelled with the square and y square is equal to this. So, this will be taken as y. Now, it is differentiated using implicit function. What is differentiation of y square? It is 2y into dy by dx, right, plus sin x plus y. See, differentiation of y square is 2y dy by dx is equal to differentiation of x sin x, differentiation of sin x is cos x into differentiation of y is dy by dx. See, then we have dy by dx two term, this is 2y dy by dx, and then this is taken to the right side, sorry, left side, it will become minus. When it is taken outside, it will be 2y minus 1 is equal to cos x. Hence, dy by dx is what? Cos x divided by 2y minus 1. It goes to denominator of the other side. This will be the proof. Suppose there is a function like y is equal to x to the power of x to the power of x to the power of x up to infinity. Here you can write in infinity, up to infinite times is given. Then it is to be reduced to differentiable form. How? By leaving first x, the other r taken as y. What is y? Y is equal to x, x to the power of x to the power of x to the power of x, like that it will go. If I leave this, again the remaining term become y only. Hence, it will become what? Y is equal to x to the power of y, y is equal to x to the power of y. You leaving first term, the other things are what? X to the power of x to the power of x to the power of x, it is to be considered as y only. It is function to the power of function, you take log on both side, then log y is equal to log of x to the power of y. Finally, it will become what? The power become index, power become index. Hence, log y is equal to y into log x. How to differentiate this? This is to be differentiated by using product rule. So, for log y it is 1 by y. For this product rule, y into d by dx of log x plus log x into d by dx of y. Keep y as it is. Differentiation of log x is 1 by x, is it right? Plus keep log x as it is. Differentiation of y, it is dy by dx only. 1 by y into dy by dx, this dy by dx term is transferred to the right side, it is transferred to the right side, it will become minus log x into dy by dx, which is equal to y into 1 by x, it is y by x. Then you take dy by dx common here, by taking dy by dx common, it will become what? 1 by y minus log x. See, 1 by y minus log x. Then dy by dx is equal to y by x whole divided by 1 by y minus log y. For further simplification, if you require, you can go it, otherwise you can stop at this stage. Then how to further simplification? Taking LCM on both sides. Here we no need of taking LCM, in the denominator only you take the LCM. What is LCM? Here is 1, therefore LCM become what? Y numerator 1 minus y into log x. If you cross multiply it, y by x into y divided by 1 minus y log x, it will become y into y square into x into 1 minus x log y log x. This is called what? Implicit differentiation of logarithmic terms. Then next part is what? It is the differentiation of parametric functions. That is very important concept. Here we have to discuss differentiation of parametric functions. You take the derivative of derivative of parametric function. Parametric functions. Let us know what is nothing but parametric functions, right. In all the functions we have discussed so far, there it will be given in what? It will be given in x and y, or it will be in two variables, that is x and y, and which is always given only one function in the form of equation. Here both the variables will be given in common variable, in another common variable, that is to be a parameter, See, if x is equal to f of theta, y is equal to g of theta, both x and y are given in terms of what? Theta. Here theta is to be considered as parameter. Common variable is to be treated as parameter, hence such functions are called as parametric functions. Those parametric functions are to be differentiated. You take example parametric functions, x is equal to a sin theta, y is equal to b cos theta, x is equal to 1 minus t square divided by 1 plus t square, y is equal to t divided by 1 plus t square. Here what is parameter? Here the parameter is t is parameter. Sometime x is equal to theta cos theta, y is equal to theta plus sin theta. Here theta is parameter. So, in parametric function there will be always two functions, two equations, both two will be given in another common variable, that may be in theta or that may be in t. That functions are known as parametric functions. How to get the differentiation of the parametric functions? I will show few examples for getting differentiation of parametric functions. So, in parametric functions, how many functions will be given? X is equal to say f of theta, y is equal to say g of theta. Then how to get the derivative of a parametric function? It is in theta, no? So, x is differentiated, differentiate x with respect to theta, we get dx divided by d theta, is it right? We get dx divided by d theta. So, I will call f dash theta. Y is to be differentiated, differentiate y with respect to theta, then it will get dy by d theta. So, dy by d theta, just I will be called it as g dash theta. Hence, we get dy by dx using this formula, dy by d theta divided by dx divided by d theta. This is known as parametric differentiation. X will be given in one parameter and y also will be given in another parameter. Both should be differentiated with that common parameter. Here we have taken x is in theta, y is in theta, x is differentiated with respect to theta, we get dx by d theta, y is differentiated with respect to theta, we get dy by d theta. Finally, dy by dx is taken as dy by d theta divided by dx by d theta. Is it clear? It is given in theta, therefore, I have taken in terms of theta. Suppose if they have given in t, then the x and y are to be differentiated with respect to t. Finally, dy by dx become what? Dy by d theta divided by dx divided by d theta. I will show the problems based on this parametric differentiation. The problem may be of this type: if x is equal to a t, y is equal to a by t, find dy by dx. It is very important problem. What is x? X is equal to a t. Differentiate x with respect to t, then we get what? Dx by dt, dx by dt, dx by dt is equal to, a is constant, keep a, differentiation of t is what? 1, finally it is a only. Then y, what is y? Y is equal to a by t. So, it can be taken as what? A into 1 by t, right. Differentiate this, differentiate y with respect to t, then we get dy by dt. So, a is constant, keep it as it is, 1 by t. 1 by t derivative is what? It is of 1 by function to the power of n, 1 by function to the power of n, it is minus n by function to the power of n plus 1. So, according to that it will become minus, what is power? Power is 1, n divided by t to the power of 1 plus 1, it is minus a divided by t square. Therefore, using parametric differentiation, how to get dy by dx? It is y is differentiated with respect to t and x is differentiated with respect to t, their ratio we have to take dt. dy by dt, it is minus a by t square all divided by dx by dt, dx by dt is what? A. So, a get cancelled, we have 1 by t square, it is the answer. It is the derivative of x is equal to a t square a t, y is equal to a by t. You got the procedure. So, I will repeat the procedure once again. The function x and y will be given in common variable, if may be given in terms of t or it may be given in terms of theta. There first step is what? We have to differentiate both x and y with respect to the given variable. So, that is x is differentiated with respect to theta, y is differentiated with respect to theta, hence it will get dy by d theta and dx by d theta. Using that we have to find differentiation of given parametric function with respect to x. Finally, you will get differentiation of x with respect to t, right. This is called the derivative of parametric function. You may work out the other examples in the next class. You just I have given a hint for the derivative of parametric function. X may be in t, y may be in t, or x may be in theta, y may be in theta, both should be differentiated with respect to given parameter. Finally, we have to find dy by dx. So, this is our discussion, and next class we will continue the derivative of other parametric functions, and one more differentiation is there, that is successive differentiation, that can be discussed in the next class. So, with this I conclude my session. Thank you very much.